Hey everybody, figured since I've been working on these disk drives, I would go through and do an alignment check and maybe try to adjust the alignment and do a speed check and adjust the speed on all these disk drives. So we'll start with this one that I already have cracked open that I've been working on, and I'm going to follow this guide from Sam's Computer Fact. I do not have an alignment disk, but I do have the original Commodore test demo disk, which should have a good format from a good drive on it to use as a baseline. So first thing we're going to do is we're going to plug in my diagnostics cart here, and this is the 1541 from World of Johnny. And we're going to use the alignment check. No, we're going to do speed check first. So S, and then I think you need to put in a blank floppy disk for this. I think if I just hit return, actually let me power this on. So no disk in it, and then it says press return, and it doesn't do anything. Because there's no, I guess because there's no disk in it, it's not going to do the speed check. And I don't think, can I break out of this? Kind of locks up the program if you don't have a disk in there. So let me turn that off. Put in a blank floppy. Turn it back on. And we'll do speed check. And now I'm getting, you can see hopefully, it's supposed to be 300 RPM and I'm getting 298. And the way we can adjust that is through VR1 right here. So let me get this maybe on a tripod, I'm not sure, but let me try to adjust this here. I adjusted that. Hopefully I'm playing some free music or copyright free music in the background. Hopefully it's not distracting, but this is basically the best I think I can get it. I think that looks pretty good. 300. I mean, it does change a little bit, but not much. I mean, I'm pretty good there, I think. So I would say that's a success. Now let me pause and come back with the diagnostic. Right, so for the alignment, did I say diagnostic? I can't talk when I'm on these, when I'm filming here. But with the alignment check, I'm going to go ahead and use this test demo disk that was formatted from the factory. And then I go into the alignment check on the World of Yanni 1541 diag. He rewrote this, so I think to get it all to fit on a cart, he had to like remove some stuff on it. But we'll hit space to check. And it took me a while to understand what this is saying, but basically what you're looking for, and hopefully you can see the colors, is you're looking for track number 1, to match. So 1 equals 1, 2 equals 2, 3 equals 3. You want to, that's the main track, and this is the read not probability, but read something. But he subtracted that, or he took that off of the menu screen there. I think it's read probability or something like that. So there's 100% read probability that we're reading track 1 or whatever, and then this is the half track, and you want to get this as close to 0 as possible. So on our half tracks, our percentage is really bad. So this drive, I guess, needs alignment. Now a lot of people don't worry about the half tracks, but I figured we should try to adjust it using the alignment check, because it looks like the regular track reading is all good, but the half track reading is all bad. That's what I see there. Alright, so to do that, there's a couple ways you can do it. One, we could just, wing it, or we can try using this alignment program from Sam's guide and actually try to look at the oscilloscope. So that's what I'm going to do first, is try to use this method, and then maybe on one of these other drives here we'll just wing it and see how close we get. All right, so to do actually a drive alignment, we have to get to the bottom of this, and this is shown on several other videos, but there's 6 screws that you have to remove, and then you disconnect your drive LED from P4, and then this will come right out like that. And you can just put it on its side or for right now or something, but I'm just going to remove this real quick out of the way. So then we have to obviously connect power to this, and we're going to have to do some jumpers and remove this connector here. So let me set up on the tripod, I think. Alright, so one of the things it says is you have to use this Dyson analog alignment diskette to do this process. So I'm doing it with you for the first time, and I do not have this disc, so we're just going to use the test demo disc here and see if we can get similar results. I have no idea if it's going to work or not using this process. And then you have to type in this program right here, which I have done right there, and we're going to disconnect P6, which is right here. We're going to disconnect this, and then we're going to turn the drive on, which we got right there, but I don't have an LED plugged in, so we can't see the green there. It says run the program above, and this the disk head will go to track 0 and then go to whatever track that we entered, I guess. Let's see here. Run the program with no disk in. The disk drive will try to find the track, then go back to track 0 and pause. It will then go to the track specified and stopped. After the disk drive stops, insert the alignment disk in the disk drive and close the door. Connect the jumper from pin 3 of plug 5 to ground. So that's right here. And what I'm going to do is actually go ahead and just raise it up just a little bit. I'm going to turn it off before I do this and connect one of my little mini clips here to pin 3. And then you can use this as ground right there. So turn it back on. Connect the jumper from pin 3 of plug 5 to ground to keep the disk drive running. And whenever the head must be set to a different track, remove the jumper from pin 3 and remove the alignment diskette, it says. Whenever the head must be set to a different track, remove the jumper from pin 3. To stop the disk drive, remove the alignment disk. Okay. Interesting. And then it says we connect our scope to pin 7 and pin 8 of UCF, which is right here. And I'm going to do that as well here off camera. And set our scope to add mode, which is going to be right here because we're going to use both channels. And let's see here, add mode, set the scope to add mode with channel B inverted. Okay, I have that option right there like that. We want 2 volts per division probably, and I guess set both of them to 2 volts per division. Set the scope to add mode be 20 milliseconds. That's 20 right there. And AC input. Gotta do AC input, I guess, on both channels. And alright, I think that's it. Let's run this program and I'll get it on the Let me see. Let me just type it and run real quick. Alright, it stopped, and then what we're supposed to do now is after it stops, after the disc stops, insert the alignment disc, which we don't have. And then jumper pin 3 to ground like this, so the motor will just keep running. You can hear it coming on. There we go. Alright, so now it's on. Alright, I'll be right back. I have everything set up right, and I don't think I'm going to be able to do anything using this scope method, but I got my B channel on pin 8 and my A channel on pin 7. P6 is disconnected, and I got the motor grounded, and that's what I get on my scope. So that's with at 2 volts per division on both, and with 20 milliseconds volts per divisions 2 and 20 milliseconds per division. So if I slow this down, you can kind of get that kind of image like that. You can kind of sort of get it at like 2 microseconds, but it says maybe he meant microseconds, but he put the M by there, so I don't know if that's milliseconds. It says 20. Let's see right here. It says 20 M seconds. Is that microseconds or is that milliseconds? I don't know. I have to look to see what that is, but I can definitely get that cat's eye view. And then it says the lobes peak to peak amplitude should be within 70% of each other, but it's kind of difficult for me to be able to see that, I guess, or be able to determine that. If the lobes are out of tolerance, loosen the stepper motor. Let's see what this looks like. That's channel 2. That's channel 1. That's both. So yeah. Can you see that okay? Let me update intensity a little bit. I mean, you definitely get a cat's eye, but you know, who knows how good my scope is or what's going on there. Make sure that both of these are on. And if I change it to track 30, for instance, definitely get a slightly different pattern. Track 5, let's see. So 16 is the one that most looks like an eye there, the cat's eye view. Interesting. Alright, so I don't know exactly what I'm going to do with that. It looks I have too many lines maybe to even say that it's 70% of each other. But at least we have something to base off of, so a baseline. Okay. The other way to do this is just to turn it on its side. This is the stepper or the drive motor or stepper motor, I don't know. And there's a couple screws, one right there and one right there. Basically, we loosen it up and adjust this, and what we'll do is run this alignment program in a loop. See if we can get that. It doesn't help it if I don't have the drive on. Let me turn the drive on. And power this on. Alignment check. And we want to hit A for loop. Alright, and while it's doing that, I'm going to adjust this and put the camera on the tripod and zoom in on the monitor, and we'll see if we can, by me adjusting it, if we get it better. Right, there we go. This could be interesting. Oh, that's worse. Interesting. It's actually adjusted all the way to one side. I can only move it to the negative. Oh, now I'm actually reading off track, which is terrible. Oh, that's actually better right there. Wow, that's like right on the nose. That's what you want right there. I just barely adjusted it. Now, a lot of people say that you can't, you're probably not going to be able to get the half tracks perfect all through. It's kind of like, but this looks pretty good. This looks real good. Hopefully I can tighten it without messing it up. Obviously I can't. That last track is last half track is off. I wonder if is that the best I can do it? It looks like it is kind of a, I might let it run through one more time. It seems like it's kind of difficult to get it perfect. Anyway, I will pause so you don't have to keep watching this. This looks a lot better than what it did, obviously. But I'll pause and see if I can get it better and then come back. Alright, so I ran it one last time, and basically what I've noticed is, like, every time I run it, if I run it again, I'll probably get slightly different results. What's consistent is this half track, probably because it doesn't go 35 and a half. Maybe that's why it's negative 100 there. But let me run it one more time while I'm filming. Press any key. Alright. Did we freeze up? Alright, let me power this thing off. Do alignment check. And we're going to just check it one time. Yeah, see, I mean, for the half tracks, I'm getting, you know, some variance every time I read the disc. I don't know what that necessarily means, but a lot of it is 0, which is good, if you can see that. Sorry about the glare on the TV there. I would say you don't necessarily need to use the oscilloscope if you have this program and a decent disc. I guess this would be good enough. I know some people say you have to use the scope and stuff. I don't know, I might put it back on the scope just to see what that signal looks like now versus before. But to me, I'm not going to mess with it anymore. I mean, this looks pretty decent, so I'll pause and be right back. Alright, I figured I'd hook up the scope back up after we adjusted it, the alignment and everything. And I guess this disc is just not right, because there's got to be something that it's reading off that disc, that what is it called? A Dyson disc, that is creating some type of signature that can output to the scope, because it definitely is 20 milliseconds, and I mean, obviously I'm not going to be able to see it. I don't see jack at that level. So I would say that without that Dyson disc, you can't use this procedure. Maybe one day I'll get one or something, or somebody will let me borrow one. That'd be cool. But anyway, what I'm going to do now is I think I'm going to try to adjust the run this procedure to adjust the headstock. So it says you still need a scope for this. You put the alignment disc in, connect the jumper, put it at track 0, and make sure to check for 125 Hertz waveform as shown right there. So I'm already connected to pin 7 of UF4. Yeah, I'm already connected to that. So let me just go to track 0, I guess. Let's see here. 0. Alright, and then it should have adjusted that, and then we'll go to just channel 1, and we're going to go to, what does it say here? 5 microseconds. 5 microseconds. 2 volts per division. And our mode is A. Yeah, we're not looking at both of them. We're just looking at A. So does that look... Well, if I do 1 volt per division... I don't know. Alright, let me put it on my frequency counter, actually. Let me see here. I got 64 Hertz, supposedly at track 0. So that's not right. Am I supposed to be on DC? No, that has no impact. Does it say go to DC or AC? No, AC input. Put it to track 0, and I should see 125 Hertz waveform. Actually, that's a multiplier of 3, so that's 664, 1, 2, 3. That's like 64,000 Hertz. Interesting. I don't know. I have to think about this a little bit. Be right back. I was messing with my scope, but I just don't think with this disc I'm going to be able to run the alignment program as it's detailed here in Sam's computer guide. So anyway, that's what I'm getting, 64,000 hertz. So obviously that's not right, and maybe that's based off of, I don't know what that would be based off of, but all right. So the only thing I can do is to adjust. We are set at track 0, so I can at least measure. It's supposed to be 0.01 inches, I think. I might have but I'd have to take off this board to actually adjust the head stop. So interesting. Maybe I'll do that. Maybe I won't. All right. So with that program, I set the track to 0, supposedly, I guess. I don't know. And then I powered it down, took off the circuit board, and this is the gap that we want to measure right there. That's the stop right there, and this is the cam, I guess. And so I didn't actually, the smallest measurement that I have on a spark plug measurement is 0.022. And just to verify that, let me zoom out some. Just to verify that my caliper is accurate. 0.22. So then I took a piece of tinfoil and just folded it over. I know this isn't super exact, but best I can do right now. And just to see if, the tinfoil itself is basically folded twice, is about 0.01. Depending on where we measure, obviously. There's 0.06. So I'm going to stick that piece of tinfoil in there, like this, and basically adjust it until it touches that. So, can I do that while on camera? I don't know. We're going to try. We're going to loosen this up. And place that piece of tinfoil in there. I'm gonna pause and be right back. All right, I think I got it. I mean, it is. Whoops. It is tight. I mean, 0.01 inches is super tight there. I don't know. We'll see. We'll see if that worked. I'm gonna put it back together and then we'll rerun the alignment program, I guess. So let me put this back together. All right, I have it looping through the alignment. Everything's back together. My alignment's looking darn good there, if you can see that. But the other thing is, I'm curious about the knocking when it's trying to going back to track 0. So I'm going to zoom in here so you guys can hopefully hear it. Track 28, 29, 30, 31, 32, 33. All right, here we go. Wow, it did barely knock at all. I mean, it found track 0 or 1 super fast. It didn't make that rattling noise. So really adjusting that definitely helped big time. Awesome. I think that's all I'm going to do with this one, with this drive. So I don't know exactly how long this video is. Maybe I'll go ahead and do a couple more so we can show that, but be brief about it. Right, I'll be right back. Drive number 2 here. We're going to first do the speed check. You can see that. What we got? It's pretty close. I'm going to adjust it just a little bit. Alright, I think that's the best I'm going to get it right there. Alright, and then now we're going to do a drive alignment. We're going to do a drive alignment. Looks like the main tracks are all good, but the half tracks is off a little bit, so just like the other one was. Alright, so that's what the before is. So I'm going to go ahead and remove the drive assembly from the bottom case, and then we'll adjust it, and then I'll come back. Alright, yeah, it looks much better already. So I just have the whole case out, and I flipped it on its side, unscrewed those 2 screws, adjusted the motor just so slightly, and we are looking pretty good. I don't know, obviously it's not the official way to do it with the oscilloscope and everything, but I assume that this is better than what it was. So the next thing I'm going to do is I'm going to power it off, and then I'll adjust the stop head, or whatever you want to call that thing, and maybe lube up the rails as well. Okay, I just went ahead and wrapped up this drive right here. I tried to clean it up. I don't know if I can get that, but cleaned up both of those drives, and we're good with that. This is the 3rd drive. We're going to do a speed test real quick. So let's hit S. I guess it wants a non-write protected disc in there when it does the speed test. That's what I can assume. Let's go. So just a little fast. Not bad though, really. Oh, this one has a different little VR1 on it. Is that a little bit better? 305, 300.2, 300.5. I think that's pretty good. Now let's do an alignment check. And to do that, we're going to put in our test demo disc. And this one looks pretty good already. I don't think I have to do anything with it. Alright, you can see there that the tracks at the end, from basically track 27 on, are pretty far off on the half track. So I'm going to try to see if I can get it better. Regardless, I'll take this board off so I can actually clean the rails and lubricate them, and then I will adjust it and come back. I took everything. I took the chat or whatever. I took it out of its case, the drive assembly, and when I went to run my alignment check, and this is after I cleaned. This is after I cleaned the rails and was moving the stepper header as well. And I want to loop, and it's not moving. Oh, I don't have it on. Actually, I did have it on. Did I? All right, it's on. It's on now. Let's see. We hit alignment, and we want to loop it. And it's not doing anything. The head's not moving at all. So I'm thinking that it lost track. So we might need to run the initialization command. Let me do that real quick. Okay, so that's the command that I typed in there. Open 15, 8, 15, and then initialize. And I took the disk out. Device is not ready. Oh, duh. I'm an idiot. I'll have to cut this part out. I don't have the damn drive, the serial port connected. I'm like figuring out what's going on there. All right, be right back. Well, it turns out that this one of the screws for the stepper motor underneath is stripped out, so I can adjust it much better than it already is. And I'm going to end the video here. Thanks to World of Johnny for making the diag cart, and hopefully that this whole process helps somebody. Until next time, bye.